Hello, I'm Bob Allison, WB1GCM, ARRL test engineer, here in San Jose, California, at the AMSAT Symposium. And I'm with Keith Baker, KB1SF, past president of AMSAT. Hi, Keith. Thank you for joining me here in this room.
My pleasure, Bob.
And I just want to explain to our members what AMSAT is.
AMSAT is the follow-on organization to Project Oscar. You had another gentleman in here was talking about the early days with the Oscar 1 satellite.
Lance Jenner, yes.
That was Lance Jenner. Well, along about 1969, a group of East Coast hams in the Washington, D.C. area decided to start the East Coast version of the West Coast Project Oscar, primarily to see if they could get a launch for the Australia's 5 or Oscar 5 satellite. They got together in the Washington, D.C. area and formed the Radio Amateur Satellite Corporation, or AMSAT as it's now called, in 1969. And from that point forward, they did get a launch for Oscar 5, and they went on to build, and of course by this time NASA had started to do launches versus the early days of Oscar, which was Air Force
rockets, yes.
So a lot of the people that were associated with AMSAT were in the DC area. Many of them worked for NASA, and so they were able to secure launches for the satellites that followed Oscar 4, and then Oscar 5, and Oscar 6, Oscar 7, which Oscar 7 is still working.
It still works.
Which was a big surprise to a lot of people.
It came back.
It came back to life after finally, I think it finally went off the air about 1981 yeah, 1981. And it was miraculously discovered by a ham in another one of our AMSAT members in England who happened to be looking for interlopers, his words, on the amateur satellite bands, and all of a sudden heard this Morse code and said, "That sounds familiar, but which one? Which satellite?" And it turned out it was Oscar 7.
Just by chance. Amazing.
Just by chance,
Wow.
because the batteries had shorted in the open position, which meant that if the solar panels were illuminated, then it came back to life, and it's still in use today.
That's great. That's a great story.
I mean, it's something.
And when was that launched?
It was launched in 1974.
Wow, that was the year I got my first novice license.
1974.
Wow.
So it's like the proverbial Timex watch. It takes a licking and keeps on ticking.
That's great.
It's just amazing, and I use it all the time. It's a fantastic satellite.
Well, what other satellites have AMSAT been involved with?
We have been, since that early period, there have been several, I would call them revolutions in terms of amateur satellite work. One was the microsats.
Very small.
Very small.
Is this an example of the microsat
Actually,
in front of us?
this is called a nanosat.
Nanosat, yeah.
But the microsats were about 9 inches on a side.
Oh, that's small.
They carried, they were about 20 pounds.
Yes.
And of course, now you have to remember, this is 1980s technology. But what happened was that there were too many satellites chasing too few launchers at the time.
Right.
And some of AMSAT's experimenters who like to come up with ideas and literally came up with the idea for these microsats on the back of an envelope at one of these conferences. They were all sitting up late at night in somebody's hotel room, and they all started writing things down and saying, "Oh my goodness, let's try this." And because at that time the electronics has started to shrink, and this is to be now in the late 70s, and they came up with a design for what since has become a microsat, and they also went to ARRL, which was the European launch consortium, and said, "Hey, if you wish, we could build these small satellites and put them on a mounting ring," which later became known as the ARRL structure for auxiliary payloads, and ended up, along with the University of Surrey, which Surrey Satellite Technology now, launched 4 of these microsats and 2 of this, what they call Surreysats, which were much larger.
Is it all at once?
All at once.
Wow.
In 1990.
It's a lot of bang for the buck.
In 1990. And of course, and this is what AMSAT does, is it's a version of you scratch my back, I'll scratch yours. And essentially what happens is we will go to a launch agency and say, a launch agency, particularly if they've got a new rocket, Because you stop and think, if somebody's going to build a multi-million-dollar satellite, they
They
don't
won't
want to
put it
put
on
it
the first one.
on the first one.
Yeah.
So AMSAT says, throw us in that briar patch. We'll go ahead and be your experimenter, because the launch agency likes to have real satellites, because then they can turn around and sell that to their customers and say, yes, we've really launched a satellite with this new rocket.
Yep.
So that's what we did with the Ariane, and that auxiliary structure concept was later used with our Phase 3D, which later became Oscar 40.
Mm-hmm.
So, and those satellites were the forerunner of a lot of these low Earth, what we call store and forward satellites.
The
that
packet.
use the packet satellites. That later, those models later morphed into some commercial designs, that you may have heard, like Iridium and Global Star and those sorts of things. So in many ways, this is a classic example of where amateur radio has spawned a whole new industry. And
Indeed.
some of the work that AMSAT has done.
Indeed,
So it's just phenomenal.
that's terrific. Now let's talk about today. Recently, AMSAT was involved with their SAT, right?
ARRSAT 1. There's several of the folks are here at the convention that were absolutely instrumental in that design. It started off as a project called SuitSat, which some folks may
Remember that.
remember, where they put some radio equipment and a couple of antennas on the fellow's helmet, and they threw the spacesuit out the door.
That was a gory sight. Just watching that spacesuit kind of like drift away.
Yes, in fact,
it's like that was really spooky.
In fact, one
But
of
interesting.
one of the cosmonauts, as they were drifting off, made the comment, "Goodbye, Mr. Smith." But anyway, they wanted to do a follow-on to that, which was called SuitSat 2. And for one reason or another, the spacesuit became unavailable. But our Russian compatriots said, well, we'll still give you the upmass to get it up there, and we'll still give you the EVA to launch it, but you guys are going to have to come up with some kind of a space frame. So what happened in that world was we ended up getting some donated parts from the Russians. One was the battery. We also obtained some solar cells from NASA, and did something else that AMSAT has always done, is that because we use a lot of times use leftover pieces and donated labor, we matched the spacecraft design to the size of the solar cells.
I see.
So it became a fairly large piece of equipment. It was of this side, and I'm sure you'll have some footage of this later on when you're actually doing your programming. But we ended up with a satellite that's about like this, with lots of space inside, and that became ARRSAT 1, which has since been launched off of the International Space Station. Cosmonaut literally
I watched the video.
took it
Manhandled that
outside the
thing.
airlock and literally let it go.
Yes.
I like to say that there was one of the early designs, or one of the early ideas that was kicking around with some of our experimenters, was called PizzaSat, which
Okay.
was to put a bunch of radio equipment into a pizza box and toss it outside the shuttle. Well, this was son of PizzaSat, I guess you could call it. But anyway, that's what happened with ARRSAT, and that has since, it's still in orbit as of this time. It's been in orbit for about 3 or 4 months now.
Yes.
Designed predominantly to get school children in this science, technology, engineering, and math, this STEM idea, to get them interested in those sorts of things.
I think there's no better venue to get kids interested in amateur radio than satellites, and this is a great example.
Absolutely,
That's
absolutely.
terrific.
Because space is interesting still. I mean, there's a lot of interest in.
It's a frontier.
Absolutely, and the fact that amateur radio is there, and the fact that groups like AMSAT are continuing to keep it there, is just absolutely exciting. The ARRIS project, where we have the school children talking to
Yes.
the astronauts, literally changes lives, because those kids get so excited and they can say, hey, I actually talked to an astronaut in orbit. And that is really...
And many, many hundreds of kids all around the world have actually had that experience.
Yep. Yeah. And it's really amazing that I can, with a piece of equipment that I have in my hand, that I, as a ham radio operator, can stand outside, and I've done this. I've stood outside my house and watched the shuttle or the International Space Station go overhead and have actually made a contact.
Right. And that's big up there. You look up there, and it's pretty big sometimes. It's pretty bright.
Big, but the fact that I, as John Q. Public,
Yep.
can actually communicate with an astronaut and have them excited about talking to me, and that's the other part of the ARRS project, which is just another aspect of this. This is the next generation of what we're going to be building. These are called CubeSats. This is a full-size engineering model, and what we're saying now is with the advances in solar cell technology in terms of the efficiencies of the solar cells, as well as the miniaturization of the electronics, we're able to make a microsat-sized satellite have the equivalent.
That's amazing.
Because the launch costs are very expensive.
Certainly, and weight's everything.
We're talking hundreds of thousands of dollars for a microsat-sized satellite, but this, because it's shrunk down now, we're able to cram as much power and as much electronics into something this size. And by the way, this whole concept was, if you will, invented by another group of hams that we've been associated with over the years, one of whom was part of that microsat project. So this is where we're going. These are launched out of a little thing called a P-pod, which goes on the side of a rocket. It's got a spring on one end. You literally push them in, and you have a little door that closes, and then when it's time to launch, the door opens, and out they pop. So,
marvelous.
We are in the process now of building our first one of these CubeSats. It's going to be called Fox 1. Fox for AMSAT satellites have gone with a letter designator before they've been launched. With Oscar A, Oscar B, Oscar C. Once they're in orbit, we give them a number. So this is the F series, so that's where the Fox comes from. AO51, which is a very popular satellite, has been. Unfortunately, its batteries are starting to fail. That's why that was called Echo before launch. So this is Fox.
Well, life expectancy in space for something like that?
Depends. It depends on the orbit. For example, the ARRSat is probably not going to last more than 3, 4, or 5 months because it's in an orbit similar to where the International Space Station is.
So it doesn't have that exposure.
It doesn't have, well, it's, believe it or not, there's air up there at that altitude.
Okay.
It depends on how much you got hanging in the wind. But we're expecting that it's eventually going to, sometime in the next year, it will deorbit.
I see.
If these are launched, let's say, into a 350 or a 400, 500 kilometer orbit, you're talking 5 years or more. Depends. A lot of times, unfortunately, battery technology still hasn't kept up with a lot of the electronics, and a lot of times what we call the long pole in the tent is the batteries. They'll fail. Now, what we're planning to do with this satellite is to try and replicate and actually plan for what happened to Oscar 7, which is if the batteries fail, if it's in the sun, it will be on. If it's not in the sun, it'll be off, and it will automatically spring to life. So even if the batteries fail in orbit, we'll still have a satellite until such time as it deorbits.
I like that. That's
great.
great.
Well, it's called planned in obsolescence.
Yes.
But it's planning for obsolescence.
Certainly.
Anyway, of course, this one is another version where we have deployable solar panels. So that's kind of where we're headed, at least in the next couple, 3 years.
So the future of AMSAT's pretty good.
I would say so. The future is looking bright. We're always looking for experimenters to assist us. We use a lot of donated labor and leftover parts. Some parts we have to buy, some expertise we have to buy. But we say we're an equal opportunity exploiter, and if you really want to get in on the ground floor of working something that is absolutely on the cutting edge,
yes,
we certainly could. We'd like to have you as a member as well.
I just signed up.
We're a membership organization, just like the ARRL.
Yes.
We rely predominantly on member donations to fund what we do.
Yes.
And it's amazing what we've been able to do literally on a shoestring.
Quite remarkable, really. Yeah. Well, Keith Baker, KB1SF, thank you very much for joining me here at the AMSAT Symposium, and thank you for all your work you've done on behalf of Amateur Radio.
Thank you, Bob.
Thank you very much.
It's been a pleasure.